Hello, I'm Carlos Rosas, and this is the CRS channel. We're going to continue with our physics problems in kinematics. And we're going to pass on to problem 9. So here we're going to work a bit on using the spreadsheet as we did in problem 8. Some small details with reference to problem 8 will be explained here also. Okay, so let's go on to the spreadsheet. Here we have a data table where we have the values of time and position for the motion of particle. The values are given from time t equals 0 to time t equals 6 seconds. And on this column we have the values for the position of the particle in meters. So, what is asked of us to do? We're supposed to calculate the values of velocity and acceleration, and for that the following formulas will be used. We have that v is approximately equal to delta x over delta t, so that any given value vi plus 1 will be equal to xi plus 1 minus xi over ti plus 1 minus ti, or can be also calculated as vi plus 1 approximately equal to 1/2 of the sum of the ratios xi plus 2 minus xi plus 1 over ti plus 2 minus ti plus 1 and xi plus 1 minus xi over ti plus 1 minus ti. For the acceleration we have similar formulas. A is approximately equal to delta v over delta t, that is ai plus 1 is approximately equal to vi plus 1 minus vi over ti plus 1 minus ti, and or equal to 1/2 of the sum of the ratios vi plus 2 minus vi plus 1 over ti plus 2 minus ti plus 1 and vi plus 1 minus vi over ti plus 1 minus ti. Okay, here we must add that if ti plus 2 minus ti plus 1 equals ti plus 1 minus ti, then these two ratios, these two fractions have the same denominator, and therefore these two, by adding these two xi plus 1s cancel out, and we also have that ti plus 2 minus ti plus 1 will be equal to ti plus 1 minus ti, and will be equal to 1/2 of ti plus 2 minus ti, which means that simplifying and canceling out the halves, we have then that this vi plus 1 can also be calculated as xi plus 2 minus xi over ti plus 2 minus ti when the time differences are equal. The same happens here. So we will present calculations of the velocity and the acceleration according to these formulas, and to the extra one of xi plus 2 minus xi over ti plus 2 minus ti for velocity, and vi plus 2 minus vi over ti plus 2 minus ti for the acceleration. Okay, so here we have the calculations as they are performed in the spreadsheet. First of all, since we're using formulas to perform the calculations, we must always write down the equal sign first, otherwise this text here will be considered only as text and not as a formula. Okay, so here you can see B4 minus B3. So you have column B and you have row 4, and therefore you have cell B4 corresponds to B4 written here. Here you have column B, row 3, so here you have cell B3. The same happens with A4 and A3. This is A4, this is A3, this is A8, this is C7. So B4 minus B3 over A4 minus A3 gives me the difference in position over the difference in time to give me the approximate value of velocity, which will correspond to the cell C4. Okay, since you can see that this formula is repeated throughout this column, you do not have to write down the formula for each cell. You only write down the formula for the first cell for which you will do the calculation. Here you can see this little square at the bottom right corner of cell C4. All you have to do is put your cursor on top of that square and you'll notice a crosshair. By pressing down the left button of the mouse and dragging down the column down to the last value to be calculated and releasing afterwards the left button of the mouse, you will have extended the use of the formula down to the end of the column. As you can see, the formula is the same as you go down column C. You do the same thing for column D as well as for column E. That's the column for the ratios of x over t. This is the column for dx dt in accordance to this formula here. This is the column corresponding to the use of this column here. And these two are the columns for which it has been assumed that it is possible to use the expressions xi plus 2 minus xi over 2i plus 2 minus ti and vi plus 2 minus vi over ti plus 2 minus ti. As you can see, the values are not very different. We have value for v, so the value of dx dt. And these two columns are practically the same, with the exception of these two cells. For the case of the velocity, the velocities here are a bit different from this calculation. But not that much. You can make an estimate of the percent difference for any two values. For example, if we take these two values, 13.14 and 14.52, you get about 10% difference between these two values. So the differences expected are not much greater than that. 10% difference is more or less an acceptable difference between calculated values. These are the graphs for the position versus time, the velocity versus time, and the acceleration versus time in accordance to the initial values given and the values calculated for these two columns C and D. Okay, we'll continue with the rest of the problem in the next video.